In the last days of the Cretaceous world, a lone Tyrannosaurus rex moves across an open coastal plain. The space around it is wide and simple. There are no forests pressing close. There are only low plants, warm air, a distant line of water, and a sky that feels too large for one animal. This Tyrannosaurus rex is not a movie monster. It is not a dragon. It is not a guess made from fear. It is a body rebuilt from evidence, bone by bone, trace by trace, question by question. So how did scientists restore Tyrannosaurus rex from stone into something that feels alive? The story begins after death, not with roaring, not with hunting, but with a body falling silent in the ancient world. A Tyrannosaurus rex dies on a floodplain in what is now Western North America. Its muscles decay. Its skin disappears. Its organs return to the environment, but some bones remain. They are covered by sediment. They are sealed away from weather. Minerals slowly enter the spaces inside them. The animal becomes a fossil, not the original living creature, but a record strong enough to survive about 66 million years. Millions of years pass. Seas rise and retreat. Rock layers form and break. The ancient plain becomes Badlands. Wind opens the stone, rain cuts through the hills, and one day, a piece of bone appears at the surface. This is where restoration truly begins. A fossil hunter sees texture that does not look like normal rock. The color is different. The pattern is different. The shape carries intention. A fragment of life is showing through the stone. Field paleontologists mark the site carefully. They do not simply pull the fossil out. They map its position. They record the rock layer. They study the surrounding sediment because the place matters as much as the bone. The rock tells them the age, the environment, the way the animal may have been buried. The fossil is part of a scene, and the scene must not be destroyed before it can speak. Around the bones, there may be teeth, ribs, vertebrae, fragments of the skull, pieces of the pelvis, massive limb bones. Each piece is fragile. Even a giant predator can become delicate after deep time. Scientists cover the exposed fossils with protective material. They wrap them in plaster jackets. They move them slowly from the field to the laboratory. The Tyrannosaurus rex leaves the ancient plain again, but this time it travels as stone. Inside the lab, the work becomes quieter. Technicians remove rock grain by grain. They use small tools. They clean cracks. They stabilize weak areas. A fossil that looks solid can split under pressure. So every movement matters. This is not treasure hunting. It is surgery on deep time. As the bones emerge, the animal begins to return. A tooth shows the shape of a predator built for crushing. A femur shows the power of the hind limb. A vertebra shows where muscle once attached. The skull shows a deep head with strong openings. Every surface is information. Every scar is a clue. Every attachment mark says something about flesh that is no longer there. Scientists compare these bones to other Tyrannosaurus rex fossils. No single skeleton gives every answer. Some are missing tails. Some are missing arms. Some preserve skulls better than hips. Some are crushed by pressure from the rock. So restoration depends on comparison. One specimen fills the gap of another. One skull helps correct another skull. One leg bone helps estimate the proportions of a missing leg. The animal is rebuilt as a species, not just as one individual. The skeleton is the framework, but bones alone do not make a living animal. To restore Tyrannosaurus rex, scientists must ask how the bones carried weight, how the joints moved, how the muscles pulled, how the head balanced, how the tail countered the body. The old image of Tyrannosaurus rex once showed a dragging tail, a slow upright posture, a creature standing like a giant lizard statue. But the bones did not support that forever. The tail vertebrae, hip structure, leg proportions, and balance of the body pointed toward a more horizontal animal. The torso leaned forward. The tail stretched behind, the head was carried ahead of the hips. The whole body worked like a living bridge of force. This changed the way people saw Tyrannosaurus rex. It was not a clumsy tower, it was a powerful theropod with balance and momentum. To rebuild muscles, scientists use living relatives. Tyrannosaurus rex is extinct, but it belongs to Theropoda, and birds are living theropod dinosaurs. Crocodilia also helps as a living comparison outside the dinosaur line. By studying birds and crocodilians, scientists can estimate where muscles attached, they can infer soft tissue patterns, they can test how joints may have worked. This method is called the extant phylogenetic bracket. It does not invent anatomy from nothing. It uses living animals to frame extinct ones. When a muscle leaves a mark on bone, that mark becomes a starting point. The jaw of Tyrannosaurus rex received special attention. Its teeth were thick, curved, and deeply rooted. They were not thin cutting blades like those of some other predators. They were built to puncture and crush. The skull had spaces that reduced weight, but the overall structure was massive. Bite force studies suggest a predator capable of breaking bone. This matters for restoration because behavior shapes anatomy. A head like that was not decorative. It was a feeding machine. When the restored Tyrannosaurus rex walks alone across the open plain, it carries a skull made for impact. Its eyes face forward enough to help with depth perception. Its neck supports sudden movement. Its jaws close with terrifying precision. But even here, scientists must be careful. They do not restore anger. They restore mechanics. They do not restore evil. They restore anatomy. The arms are also restored from evidence. They are short compared with the body, but short does not mean useless. Each arm had powerful muscle attachments. Each hand carried 2 functional fingers. Scientists still debate exactly how Tyrannosaurus rex used them, but the bones show they were real working limbs. Not mistakes, not jokes, not decorations. The legs tell another story. The femur is huge. The lower leg and foot show an animal adapted for strong movement. It was not a cheetah-shaped runner. It was an enormous predator with mass and reach. Its locomotion is studied through biomechanics. Computer models test stress, joint range, muscle force, and balance. Some results suggest it could move efficiently, but probably not like a lightweight sprinter. The restoration becomes more honest when it accepts limits. Tyrannosaurus rex was powerful, but physics still ruled its body. Skin is harder to restore than bone. Soft tissue rarely fossilizes, but sometimes related tyrannosaurids preserve skin impressions. These impressions suggest areas of small scales. Other tyrannosauroids show evidence of filament-like covering. This creates a careful debate. Was adult Tyrannosaurus rex mostly scaly, partly feathered, or different across age and body region? A responsible restoration does not pretend certainty where evidence is incomplete. It may show scales on much of the body. It may allow limited filament-like covering in places. It must not turn uncertainty into fantasy. Color is even more difficult. For Tyrannosaurus rex, no complete color map exists. Scientists can sometimes infer color in other fossil animals when microscopic pigment structures are preserved. But for Tyrannosaurus rex, most reconstructions use informed restraint. Earthy tones are plausible. Countershading is possible. Display markings are possible, but exact colors remain unknown. So a restored Tyrannosaurus rex should not be treated as a final portrait. It is a scientific hypothesis wearing skin. Now place that animal back into its world. The time is the late Maastrichtian age of the Late Cretaceous. The place is a warm region of ancient North America called Larimedia. Tyrannosaurus rex lived with other dinosaurs and animals that were not background decorations. Triceratops horridus shared the landscape. Edmontosaurus annectens moved through the same broad environment. Ankylosaurus magniventris carried armor across the same world. Pachycephalosaurus wyomingensis may have lived there too, as darchid pterosaurs such as Quetzalcoatlus northropi moved through the air and open spaces. This was not an empty monster arena. It was an ecosystem. The environment can be shown simply: a wide plain, low vegetation, warm light, a distant water channel, open air. No crowded jungle is needed. Tyrannosaurus rex did not need a fantasy forest to feel real. Its world was already strange enough. In that simple ancient setting, the animal walks alone. Its tail balances the forward weight of the skull. Its feet land with controlled force. Its body is heavy, but not shapeless. The muscles follow the skeleton. The skeleton follows the fossil evidence, and the evidence follows the rock. This is how restoration works. Not by imagination first, but by constraint first. A scientist asks what the bone allows, then what living animals suggest, then what physics permits, then what the environment supports. Only after that does the image become complete. The lonely Tyrannosaurus rex on the open plain is a visual scene, but behind it stands a chain of research. Excavation, preparation, comparison, anatomy, biomechanics, geology, and ecological context. Each step removes a little darkness from the past. Still, a restored Tyrannosaurus rex is never finished forever. New fossils can change the posture. New studies can change the muscle model. New skin impressions can change the surface. New trackways can change the movement. Science does not restore the animal once and then stop. It restores it again and again, more accurately each time. That is why older reconstructions look different from modern ones. The animal did not change. The evidence did. The questions improved. The methods improved. The confidence became sharper, and the mistakes became easier to see. So when we look at a restored Tyrannosaurus rex, we are not just looking at a dinosaur. We are looking at the history of how humans learned to read bones. We are looking at the discipline to say yes when evidence is strong, maybe when evidence is partial, and no when imagination goes too far. The result is more powerful than fantasy because it was real. A real animal breathed in the heat of the Cretaceous. A real animal watched Edmontosaurus annectens move in the distance. A real animal may have faced Triceratops horridus on the open plain. A real animal grew from a hatchling into a giant predator. A real animal carried scars, hunger, strength, age, and instinct. Then it died. The world buried it. Time changed it. Stone protected it. And science brought it back into view. Not back to life, but back to understanding. That is the restoration of Tyrannosaurus rex. A body rebuilt from fossils. A movement rebuilt from mechanics, Atcholzo. A surface rebuilt from clues. A world rebuilt from rock layers. And a presence rebuilt from evidence. In the final image, the Tyrannosaurus rex stands alone under the ancient sky. The environment is simple. The plain is open. The plants are low. The air is warm. There is no need to crowd the frame. The animal itself carries the story. Every tooth says predator. Every bone says structure. Every step says balance. Every unknown says caution. And every discovery says the past is not silent. It is waiting for someone patient enough to listen.